Hi, welcome to video 17D. We're going to do a new problem with two proportions. We'll look at a hypothesis test and a confidence interval. So, in a sample of 400 Cecil students, 49% had a GPA of 3.0 or higher, while in a sample of Hartford students, only 46% had a GPA of 3.0 or higher. So we want to know, is this statistical evidence that Cecil students have a higher proportion of students with a 3.0 GPA as opposed to just normal sample-to-sample variation? So run the appropriate test, performing all steps, use a 1% level of significance. So let's first go back and look at the data and sort of summarize that, and then we'll set up our hypotheses. So what did the data say there? At Cecil, 49% of the students had a GPA of 3.0 or higher, and we were looking at 400 students. It's not given in the problem, but we could have figured this out. At Cecil, out of 400 students, 49% of them had a GPA of 3.0 or higher. If you take 49% of the sample, that equates to 196 students there. Same thing, we could look at Hartford. There we looked at 700 students. And out of them it said 46% had a GPA of 3.0 or higher. And again, if you took 46% of the 700 students, that would mean 322 students had a GPA of 3.0 or higher. So that's sort of our information from our samples. And now we want to know, you can see it was a 3% difference. Is this a big enough difference to conclude that Cecil students have a higher proportion of 3.0 plus students? So let's set up our hypotheses. We'll set up our hypotheses, and then we will check to make sure that the conditions for hypothesis testing have been met. But first, for hypotheses, it's a proportion problem. We've got two populations we're comparing, Cecil and Hartford, so it's a two proportion problem. We will assume to start that the percentage of students at Cecil is the same as the percentage of students at Hartford that have a GPA of 3.0 or higher. And we're looking to see, can we show that the percentage is higher at Cecil? So can we show that this is greater than? I'm probably going to start writing C's and H's instead of writing those words all the way out. And one last comment before I erase this and check our conditions. Eventually, when you do a hypothesis test with two proportions, you know that you're going to need that pooled p-hat value. So what if we pooled all the students together from both schools? What would that pooled value be? So while we have that sample information up, I'm going to go ahead and compute that. So using this, let me look at that p-hat pooled value. Remember, you get that by taking the number in the first sample and the second sample that were sort of your successes there out of your total sample sizes. So if we take the 196 students at Cecil plus the 322 students at Hartford and look at that out of the total sample size, you ought to be able to figure that out. We get a pooled value here of about 0.470. Sorry, 0.471. So eventually we're going to need that value to conduct our hypothesis test. So we'll hang on to that for a minute. Okay, next let's check our conditions. So I'm going to erase this, we'll check our conditions, and then we'll get to computing our test statistic. So let's just mention those conditions. Same conditions we've always had when hypothesis testing with proportions. So our variable is categorical. You either have a GPA that's 3.0 or higher or you don't. We're supposed to have a random sample or at least an unbiased sample. There's nothing in the problem that insinuates we collected the data in some crazy manner here, so we'll assume that the samples are unbiased. Our sample size should be less than 10% of the population. We had 2 samples. Cecil, we sampled 400 students. Hartford, we sampled 700. 700 is definitely fewer than 10% of all Hartford students. 400 at Cecil's close, but our population is always changing, and it's pretty close there. So our sample sizes, I'll say at Cecil, and our sample size at Hartford are close to being less than 10% of that population sizes. It's really just close for Cecil. At Hartford it definitely is, but those population sizes are constantly changing, so this is probably just fine. And then the last condition, you have to have at least 10 successes, at least 10 failures. That's clearly met. There were like 196 out of 400 Cecil students that had high GPAs, so another 206 of them, 4 of them would not. At Hartford it was 322 out of 700, so there's more than 300 students there that would fall into the failure category. So clearly there are 10 or more successes and failures in both samples. Not even close there on that one. So it looks like conditions are met, and so we can go ahead and conduct our test. The next thing we'll do is go ahead and compute our z-test statistic. So let me erase this. I'll go ahead and fill in the numbers. I'll kind of talk about this. If you prefer to write down the formula, go right ahead and flip back one page and write down your test statistic formula here. But we look at the difference of the 2 sample proportions on the top. So at Cecil, this was 0.49. At Hartford, it was 0.46. We're going to look at that difference. And then we'll divide by the standard error where we're using that pooled p-hat value. So we'll take a big square root. The pooled p-hat value that we previously had up here was 0.471. We'll take that times 1 minus 0.471. Divide by our first sample size. At Cecil, we sampled 400 students. And then we'll do something similar over here, where we take our pooled value again, 1 minus that, and divide by our second sample size, which was 700. Make sure you're taking the square root of all of that. Practice putting that in your calculator. Make sure that you can get a z-score here, a test statistic of 0.959. That's our test statistic. Think about what that means. That tells us that the difference of just 3% in those sample proportions is not even 1 standard error away from, a difference of nothing there, away from 0. So not even 1 standard error away. And next thing we'll do is go ahead and get the p-value for that. I'll leave this up here, draw a picture. And this is nothing new. The test statistic for 2 proportions is a bit new, a little bit more complex than it was for 1 proportion, but finding the p-value is exactly the same as it always has been. You computed a z-test statistic. If this is z, 0's in the middle, 0.959 be somewhere about over here. If we recall back to the alternative hypothesis, it had a greater than sign in it, so we shade the area greater than our test statistic, and that area is the p-value. Get on StatCrunch, use that normal calculator, and you ought to be able to find this. So pause this, make sure you've opened up StatCrunch and you can get that, but the p-value, let's see, you get will be about 0.169. Pretty big p-value, right? Definitely bigger than 0.05, even bigger than 0.10. So it doesn't look like we're finding any evidence there in favor of that alternative hypothesis. So I'll erase this and we'll write up our conclusion here. So after we compute our test statistic and the p-value, write your decision, and then also make sure you include a sentence in the context of the problem as to what you found here. So our decision, since that p-value is big, and actually I think in this one you were even given a level of significance. We were supposed to be comparing this to a 1% level of significance, 0.01. Clearly that's bigger than 0.01. So maybe we'll even say this. The p-value is greater than that level of significance. And so we're going to fail to reject the null hypothesis. We did not find any evidence at all in favor of that alternative. And so we'll say something to that effect with our conclusion. All right, so conclusion, put it back in context here. We were looking to see if we could find evidence that at Cecil we had a higher proportion of students with a 3.0 grade point average. And you know what? We didn't find any evidence of that. So that's pretty much what we're going to say here. We did not find evidence that the percentage of Cecil students with 3.0 or higher GPAs, we didn't find any evidence that the percentage is any higher at Cecil than it is at Hartford. All right, so that is our hypothesis test for this one. Second part of this one, we're going to compare a confidence interval. We've talked before about how hypothesis testing and confidence intervals, you're really kind of doing the same thing. So we'll just see how these relate to one another. You should not get any different results based on your confidence interval. Your confidence interval should agree with what we found out here with our hypothesis test. So support your test with results, support your test results with a 98% confidence interval for the true difference in the proportion of students with high GPAs, and we'll interpret that. All right, so first thing, why a 98% confidence interval? Back in part A, you were told the significance level is supposed to be 0.01, 1%, and it was a one-tailed test, right? So if you think sort of that standard normal curve, if we want to construct a 98% confidence interval, that would mean that the area in each one of these tails would be 0.01, right tail test out in the right tail. There's your level of significance. So when there's an area out in the right tail of 0.01, that equates to a 98% confidence interval here. So we might write a comment about that. A one-tailed test is going to be equivalent to a 98% confidence interval. that area in the right tail there is 0.01. Kind of see the same thing from the picture there. All right, so let's get our confidence interval here. For a 98% confidence interval, you're going to need that critical z-score. Make sure you can figure out what that critical z-score is that goes right there. Even drew the picture for you already, so do you know what that is? Pause the video if you need to. Open up StatCrunch. You ought to be able to get that. This is going to use a z-score of 2.33. You round that z-score to 2 places. Just to summarize some information, recall that our p-hat for Cecil was 0.49. Your sample size for Cecil, this is the first sample here, was 400. For Hartford, it was 0.46, and we sampled 700 students. You ought to be able to get that confidence interval. Remember, it's your best guess. It's the difference between these, plus or minus the margin of error. The margin of error started off with that critical z-score there, times that standard error. So pause this, try this, unpause it in a minute once you have it, and let's see if you get the same thing. All right, so you should have gotten a confidence interval that goes from negative 0.0428 to positive 0.1028. Again, you don't have to write that positive, but this does kind of emphasize that, hey, this interval ranges in values from a negative difference all the way up to a positive difference. So it's good for the first couple here to sort of emphasize that by putting that positive. And if you look at this, this totally agrees with what our hypothesis test said. For the hypothesis test, we were trying to figure out, hey, is the percentage of people with these high GPAs, do we have more of them at Cecil than there are at Hartford? And if you look, there's a critical number that falls right inside that confidence interval. A difference of 0 is inside this interval. So we did not find evidence to support that alternative hypothesis that the percentage is higher. Had the entire interval been positive, if I cover up that negative for just a second, if that interval had gone from a difference of positive 0.04 to positive 0.10, then we would have found evidence. But whatever you found with your hypothesis test should agree with what you find with your confidence interval here. Okay, so I'm just going to erase a little bit and just write up a sentence interpreting what we found here, and then we'll be done with this one. So you could write a couple of things, but we are 98% confident that the difference in the percentage of students with these high GPAs at Cecil versus Hartford is in that interval. I wish I had said this a little differently. We're confident that the interval contains that difference. Our interval, I'm going to squeeze that in here, contains, it's not quite the same thing if you say it the way I was headed. The difference in the percentage of students with high GPAs, difference. Again, it's okay if you also want to say this, that's kind of more the formal interpretation that Joe had talked about, sort of a more informal interpretation. this would say that our interval goes from having a difference where Hartford students have a higher GPA 4% of the time, or 4% more likely, all the way up to Cecil students. The difference here is 10%. So obviously a difference of 0 there is right in the middle, not right in the middle, but it's in the interval. So we didn't find evidence that the GPAs are any higher at Cecil, or the percentage of students with the high GPAs is any higher at Cecil than it is at Hartford. So completely agrees with what we found there from Part A. All right, so that's it for this one. We'll be back with one more video, I think, in this lesson to do another example. Thanks.